Hello, this video is on a review of Chapter 6.1 and 6.2 for statistics, which covers the probability distribution and a binomial probability distribution. The probability distribution has two conditions, and that's that the sum of the probabilities is 1, and each probability is between 0 and 1 inclusive. So first we want to distinguish between continuous and discrete. So remember, if it's discrete, if it has to be countable, like whole numbers, 1, 2, 3, 4, 5. And continuous is where we can have fractions and decimal answers. So number 1, the mass of each of the M&Ms. Okay, so the mass of the M&Ms is going to be continuous. Okay, the number of pieces of candy in the bag will be discrete. The diameter of each piece of candy, remember you have a circle, and the diameter is through the center, across the circle, so it will be the widest point, and that is continuous. The number of distinct colors is discrete, and the cost to purchase the bag of M&Ms is continuous. All right. Looking at page 2. Okay. We want to toss a coin 3 times and to write the sample space. So on the first toss, you can get a heads or a tail. The second toss, you can get, again, a head or a tail. Then on the third toss, you can get heads or tails. Okay, this is known as a tree diagram. And you read up the branch. So you say head, head, head. So you could get 3 heads in a row for the 3 times you cross. You could get a head, head, tail. Head, tail, head. Head, tail, tail. Tail, head, head. Tail, head, tail. Tail, tail, head. Or a tail, tail, tail. Okay, notice this here is called the sample space. All these outcomes here, that represents your sample space. Notice there are 8 outcomes. Okay, they're all different. All right, so we want to find the probability of a head, head, head. So if you look, there's 1 toss that's a head, 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 1 out of 8. Okay, now how about the probability of 2 tails? So we look, you could get a head, tail, tail, a tail, head, tail, or a tail, tail, head. Now notice when it says probability of 2, that means exactly 2. So that is 3 out of 8. Okay, now we have the probability of 2 or more tails. So we've got these. Head, tail, tail. Tail, head, tail. Tail, tail, head. And then the more would be all 3 tails. Tail, tail, tail. Which is going to give us 4 out of 8, which is 1/2. Now, the probability of no heads is the same as the probability of tail, tail, tail. 3 tails. So that's 1 out of 8. Now, the homework will ask you to create a probability histogram. And what's different about this is on the side, which is your vertical axis, we're going to put what the probability is. Okay, and on the horizontal axis, we're going to say how many times we could get a head. Okay, so you can get 1 head, 2 heads, or 3 heads. Now notice it's out of 8. 1, 2, 3, 4. So 4/8 is 1/2. 3/8, 2/8 is 1/4, and 1/8. Okay, so the probability of tossing exactly 1 head is 2 out of 8. Okay, so the probability of getting 1 head is 2 out of 8 if we look. And that is 1/4. And the 2 tosses that we have, exactly 1 head is a head, tail, tail, or a tail, head, tail. Okay, oh, there's one more. Tail, tail, head. Okay, so let me change that. Okay. So that probability is going to be 3 out of 8. Okay, now the probability of getting 2 heads is also 3 out of 8. Because that's going to be a head, head, tail, head, tail, head, and a tail, head, head. That gives us 2. Okay, and then the probability of all 3 heads is 1 out of 8. So we have 3 out of 8, and we have 3 out of 8, and we have 1 out of 8. So you just draw straight lines and put points at the top. And that is a probability histogram. So again, the probability is on the left side. What you want is on the bottom, in like the x-axis. Okay, so let's go to the next page. And this page is a little bit of vocabulary. So to be a binomial probability distribution, there are 4 requirements we must check. The procedure has a fixed number of trials. The trials are independent. That means the outcome of an individual trial does not affect the probability of the other trials. Okay, each trial can only have 2 outcomes. It's either a success or a failure. Success is denoted by the letter P, and failure is denoted by the letter Q. And then the probability of success remains the same for all trials. Now, what's important here are these 2 formulas. Okay, so let's recall. The symbol for mu, or for mean, it's called a mu. It's a Greek letter. It's mu x. And then your standard deviation is a circle with a little tail. That's a sigma, Greek letter, sigma x. So when I ask you for the mean and standard deviation, we're just asking you for mu and for sigma, and you have a formula. So we read. So in trials, I can tell you we do it like 5 times or 10 times, or maybe we're going to shoot 100 hoops. But it's also here where it says in a sample of 300. That's going to be your n value. So n is how many we either sample or how many times we do something. So n is 300. Your p is your probability. So it says 41%. So our success is 0.41. Okay, find the mean and standard deviation. Now we could find Q. Let's go ahead and find Q. So that's 1 minus P, which is 1 minus 0.41, which should be 0.59. 0.59. Okay, so your mu x is equal to n 300 times 0.41. Using a calculator, we get 123. Your sigma x is equal to the square root Now notice NP is the mu. So we could put 123 in there, but we'll do each piece. 300 times 0.41 times 1 minus 0.41. So using a calculator, that's the square root. Let's see what number we get. So if you do just that, you get 72.57. And then remember to take a square root. And we get 8.52 rounding to 2 decimal places. And that's all that this is. It's just basically using 2 formulas for finding the mean and the standard deviation. Okay, now, in our next example after this, we have to know these math words. So let's look at this. The first 4 are called inequalities. Okay, greater than and less than. So just to review, this is your greater than symbol. So if you have x and that symbol 4, this is going to be red. X is greater than 4. If you underline the symbol, that gives you 2 things, greater than or equal to. X is greater than or equal to 4. Okay, so in the first one, x greater than 4, 4 is not included. Second one, we're going to include 4. And again, so looking the other direction, switching your inequality sign, x is less than 3. Okay, don't include 3. So if you want to include 3, we have to make it an inequality and an underline. So x is less than or equal to 3. All right, so we are going to review a couple things here. I would like to review what it means to be unusual, and that'll be part C. So let's look at this example. A large study of returning veterans showed that 52.7% of the soldiers suffered from PTSD or similar ailment after serving in Iraq. A random sample of 200 veterans from Iraq was selected for additional research. Okay, so 200 is your n value. So n is going to be a whole number. The percent is going to be p, because p stands for probability and percent is your probability. So what is the mean? So mu x is equal to n minus p. So mu x is equal to n, 200 times 0.527. So if we multiply 200 times 0.527, we're going to get 105.4. And we know that we can't have 4/10 of a person. So if we approximate, we're not going to get to 106. So we're going to go ahead and round down. Normally, if you're wanting to know how many people, you're going to round down instead of up because you don't quite get there. Okay, what is sigma? So your standard deviation, that's your symbol, sigma x is equal to square root of np 1 minus p. So that is the square root of 200 times 0.527 times 1 minus 0.527. So sigma x is equal to 7.061. And again, you're going to do that math on the calculator. So you can do it all in one step if you'd like. Okay, and we are rounding here to 3 decimal places. Suppose that we have 110 individuals suffering from PTSD in a group of 200. Would that be unusual? Okay, so let's recall. So a value is unusual if it is less than 2 standard deviations from the mean, or more than 2 standard deviations from the mean. Okay, our mean is approximately 105. So we'll go ahead and use the value that we got, the exact value, which was 105.4. Okay, so we know that 110 is greater. So what we would like to know is that more than 2 standard deviations. So mu x plus 2 sigma x is equal to 105.4 plus 2 times 7.061. So we will pick up our calculator. And we get 119.522. Okay, so in this case, 110 is less than this. So it's not unusual. Okay, so to be unusual, we'd have to get 120 or more. All right, let's look at this one. Flights from Dallas to Chicago are on time 80% of the time. Suppose 15 flights are randomly selected and the number of on-time flights are recorded. So we're going to do a little bit more. I want to ask you about specific values now. So again, the 15 flights is N, and the 80% will be your P. So let's write that down. N is equal to 15. P is equal to 0.80. Because 80% is 80 out of 100. Okay, find the probability that exactly 10 flights are on time. Okay, so we're going to use what's called a binomial PDF. So when we have the word exactly, we're going to use a PDF. If we have a less than or more than, we use a CDF. Okay, and we are using our graphing calculator, so just so you know, it's NPX, what value you want to find the probability of. So we're going to do binomial PDF of 15, comma, 0.80, comma, 10. And this is on the calculator. So on a graphing calculator, we're going to do second vars, second button, vars. And you're going to scroll down to binomial PDF. On my calculator, it's capital A. On others, it might be a little different. And then we're going to fill in the information. So we're going to do second vars, scroll down to binomial PDF. We're going to hit enter. And then if we have an 83, we type in 15, comma, 0.80, comma, 10. My 84 asked me for trials 15, 0.80, and 10. So it asks me for P and X. It says paste, so I'll do an enter, enter. And my answer is 0.1032. Okay, and in this class, we will ask for 4 decimal places for probability. Okay, find the probability that fewer than 10 flights are on time. Okay, fewer, that means we want the probability of x less than 10. Okay, don't include the 10. So this is called an inequality. Okay, so what we have is we could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and not include 10. Okay, so on the calculator, we're going to do a binomial CDF. All of our inequalities, we're going to use C for if it's an inequality, P if it's an equal, C if it's a greater than or less than. And in this case, it's less than. Binomial CDF of NPX. And what's a little tricky here is the X will be included. So we don't want to include the 10, so we won't use 10. Okay. So we're going to do a binomial CDF of 15, 0.8, and 9. Okay. So if we do the math, again, second bars, here, scroll down to binomial PDF. I'm sorry, CDF, because it's an inequality. 15.8, 9. We're going to go down, we hit paste, and we get 0.0611. My calculator actually has 05, and you're going to round up. Okay, so now we have the probability at least 10. Okay, at least 10. So we have to think, is 10 included or not included? Well, in this case, the probability of at least 10 is x is greater than or equal to 10. So in this case, we want 10, 11, 12, 13, 14, and 15 on top. So you could do them independently, or the calculator is going to give us this value here. So if I'm going to include the 9, the calculator gives me to the left. So if I want to go right, I'm going to do 1 minus binomial CDF of NPX. And we have to just decide which number we want to include or not include. Because remember, the sum of the probabilities for probability distribution is 1. So I'm going to do 1 minus binomial CDF. I want to include the 10. Okay, so that means if you want to include that 10, you've got to drop down or subtract 1 and use 9. So 15.8 and 9. So anytime you want to go to the right, we're going to do 1 minus binomial CDF and we get 0.9389. Okay, so we can do a less than or equal to, and that's the calculator answer gives us that. To do anything to the right, greater than or equal to, at least. So if we want to go to the right, we have to do 1 minus whatever value would give us to the left. And then here, this is in between. So this is probability between 8 and 10. So the easiest way means we want 8, 9, or 10. So honestly, the easiest way is if we do the probability of x equal 8 plus the probability of x equal 9 plus the probability of x equal 10. Okay, so these are binomial PDFs. Because it's equal. And so we're going to do NPX 15.88 plus binomial PDF 15.89 plus binomial PDF 15.810. So for small intervals, this is a great way to do it. So again, using our calculator, and you can just keep adding. If you have a graphing calculator, do it one time plus. If you do second entry, it'll pull it up for you. The only problem is it is not adding for me. So I have these numbers, 0.0138 plus 0.0430 plus 0.010. Let's see. Okay, not 01. 0.1032. Okay, so if I add those up, and notice I've rounded these. I get 0.16. Okay, so we'll clean this writing up a little bit here. And that is how you do binomial PDFs and CDFs. So I would like you to go and try your homework on my stat lab. And if you have any questions, let me know. Have a great day. Bye.